Okay, hello everybody. This is the IETF111-PALS, MPLS, and DetNet joint session. My name is Andy Malice. I'm one of the co-chairs of the PALS working group. Stuart Bryant is also a co-chair of the PALS working group, but he actually will be taking more of a role of an active participant in today's meeting rather than in a chair role. And because of that, Tariq Saad from the MPLS working group has kindly volunteered to help me chair this meeting here today. Tariq will primarily be watching the queue, and also he'll be watching the chat room, and he'll let me know if there's anything in either of those that need paying attention to that I've been neglecting because I'm running the slides. I'm planning on running all the slides tonight that make the in this meeting. That makes it easier rather than trying to have everybody share their own screen. And so when people are speaking, I'll just be happy if they just say next slide when they want me to move to the next slide. And with that, I will do exactly that. So this is the note well slide. I'm sure you've all seen this many times already. So just uh, be aware that that everything that we talk about today is covered by the note well. And when you have a chance, you can find it online on the IETF website, and you can check it out. Now, the purpose of this meeting, I said, this is a joint meeting for PALS, MPLS, and DetNet. This meeting is going to be discussing basic architectural issues that have come up from drafts that have been proposing new applications for MPLS and the label stack, and different ways to use the bottom of the MPLS label stack. A very high-level agenda overview is that we'll be concentrating in two primary areas. The first is an update from the MPLS Open Design Team calls that have begun following the previous IETF meeting, and then we'll have technical discussions of in-stack indicators and metadata encoding options. I want you all to note the Open Design Team work has not completed. They have weekly calls. These calls are open to everybody. They will be continuing following IETF 111. They are announced on the MPLS email list. So if you are very interested at all in participating with these calls, just watch the MPLS working group's email list, and you will see that all the calls are announced there, along with information on how to join the calls. This is today's agenda. We're starting out with my intro, just 5 minutes. Then Stuart will be giving us a summary and status of how the MPLS Open Design Team has been working since it started following the previous IETF meeting. Then we will have, as I said before, two primary technical areas we'll be talking about. One will be in-stack indicators with Karidi, Stuart, and Hayu Song all speaking. And then we will have metadata encoding options with Hayu again and Jeffrey Zhang. We have 35 minutes reserved just for discussion of the draft. So what I would like to ask people to do is during the presentation of the drafts, if you have a question, only ask it if it's a question for clarification of a point on the slides that's being presented. And then following the presentation of all the slides, we will go into the detailed technical discussion. And the main reason we want to do that is that there's an excellent chance that if you have a technical question when you're looking at a slide, it may be answered by a subsequent slide. Either in the same presentation or in a following presentation. So as I said, only ask questions for clarification, and we will have a detailed discussion, 35 minutes or so, following the presentation of all the slides. And then we will close with Stuart giving a 5-minute summary of everything that we've talked about and what our steps will be going forward. And this is our online resources. I would like to point out that most everything that we're doing is online. I would like to thank all of the presenters today for getting all their slides in plenty of time. So everything's been uploaded to the meeting materials page. So if you want to download any of the slides, they're all available. They're all online on the meeting materials page for IETF 111. You can find the agenda at the URL you see on the slide. It's also available, of course, through the agenda page. We are taking notes using Etherpad or code IMD. They're both exactly the same thing. That's the URL for it right there. You can also get the URL from the agenda page as well. What I would like you to do is, if you open that page, you'll see that there are today's agenda has been already copied into there, and after each of agenda item, you'll see a thing that says **, notes go here, **. That's where I'd like people to type. So if you have any notes, questions, comments, of you just like to take track of what's going on in the meeting, feel free to type it in right there. Dave Sinecrope will also be, Dave Sinecrope, by the way, I should have introduced him earlier. He's our working group secretary, and he'll be taking separate offline notes. And then following the meeting, he's going to merge his offline notes with everything that was typed into code IMD as well. So everything will be recorded. He'll also be looking at what's typed into the chat window, because that's just stays put in the Jabber room, and he can incorporate anything that was of substance that comes up in the Jabber room as well. So that will all appear in the minutes following the meeting. If you have any technical issues at all, Meet Echo, the meeting audio, send an email to support@ietf.org. The IETF has basically taken all their possible things you could need help for and put it into one email spot, support@ietf.org. And we also have a live Meet Echo technician who's monitoring Jabber, the chat window, which is the same as Jabber, during the meeting. So if any technical issues pop up and you type them in there, they'll be seen by one of the Meet Echo technicians as well. And that's my closing slide here. Now I'm going to move on. And the first agenda item is going to be Stuart, who is going to be talking about what's happening in the MPLS Open Design team. So if you give me one moment, I will switch slides. And you should be able to see them now. Stuart, just say when you need me to go to the next slide.
Thank you. Hopefully everyone can hear me. So next slide, please.
I hear you just fine. So I'm sure everyone else does as well.
Thank you. Right, so I should emphasize that this report is being presented on behalf of the MPLS Open Design team, and much of this material was coordinated in the meeting we had last Thursday. Next slide, please. Right, so the ODT has met 15 times. It first met on the 8th of April 2021, and as Andy has said, this meeting is open to anyone who wishes to participate. All the minutes, meeting recordings, decisions, and some of the design work is recorded on a wiki in the MPLS area of the IETF wiki, and the URL is on the screen. Next slide, please. So the background. So the MPLS working group received a number of technology proposals for in-stack function indicators, auxiliary data indicators, auxiliary data structures to be carried below the bottom of stack. I tend to use the term auxiliary data. I think it is better than metadata, and so that's what I've tended to do. I did produce an Oxford English Dictionary sort of reasoning for this. So a summary of the operations of MPLS and the proposals that were initially received were put together by myself and published as an internet draft. There are a couple of errors in that draft that need to be corrected, and I've got 01 ready to go shortly. So this is sort of a backgrounder to get everyone up to speed with the sort of design philosophy and the essential specs that you need to know to understand how the MPLS data plane works. Together with a couple of lines on each of the proposals. So in order to work out how to satisfy the underlying needs in a way that enhances the capability of MPLS without tying our hands and limiting what we can do in the future, the MPLS and PALS teams formed an open design team and invited DETnet. I think we invited TEAS as well, but they decided that they didn't wish to actively participate. PALS is involved because it was the first working group to carry ancillary data below the bottom of stack. It did this for two reasons: the control word, many of you will be familiar with, and also the OAM that's associated with the control word. So we were the first people to do this, and so we got quite an interest in a long-term sort of interest in the subject. DETnet, of course, also does something very similar in terms of control word. Next slide, please. Right, so we identified the following work items that needed to be done. First off, to look at and examine the label stack proposals that were presented. So things like repurposing the TC and the TTL fields, use almost the entire label in a label that's not at top of stack as a data field. Introduce something that people have been calling forwarding action indicators. So this is ancillary and additional instructions compared to the top of stack label. And one of the proposals is to reuse the entropy label indicator as an FAI. And then after the bottom of stack, we have data to be carried. Or at least in most cases. So a number of proposals have been put on the table. An MPLS extension header, I think really sort of very similar to IPv6. The generic delivery function. IOAM would need to go below the bottom of stack. And then we have some questions. Is it a requirement to have multiple auxiliary data items after the bottom of stack? Is it one packet, one AD, or is it multiple ancillary data items? Can the ancillary data change its size as it goes through a P router? Should the action headers be end-to-end persistent? That is to say, should we record all the actions that happened on a packet, or should we so they're there at arrival, or is it okay to discard them? And how do we instruct some nodes to take actions along the path but not others? Next slide, please. We started some work, very fledgling work, on understanding the use cases and applications for this, because that's a really good way to drive design decisions. And so far we've identified in situ OAM, network slicing, networking that is time sensitive or time critical, that may need some additional information, and MPLS network programming as 4 candidate use cases, and we're interested in people's opinions on those, and also whether there are additional use cases that we should consider. Next slide, please. So we've come to a number of agreements in the design team. Of course, such agreements need to be ratified by the rest of the working group. And we'd like to have some discussions in this session about some of this. So we think that, and the agreements are documented on the wiki at the page at the URL shown. So we think it's important to limit the number of new assignments of base special purpose labels as much as possible. We've got about half left, and when they're gone, they're gone. We have a standardized associated channel. This comes from the pseudowire work, and a mechanism for indicating it, the so-called GAL-GASH system. We don't think we should change the way the associated channel works in any way that breaks the existing implementations. That is to say, we should do nothing to the network that stops a pseudowire continuing, or a DetNet service continuing to work exactly as it does today. The ACH is found immediately after the label carrying the bottom of stack bit. Currently, there is no defined way of carrying multiple ACHs in the same packet. So our thought is that GAL-GASH should only be used as an OAM or instrumentation tool, and will not be used to carry metadata or ancillary data with user traffic. And that's the way it works so far. That's GAL-GASH. I didn't say the ACH. Next slide, please. Any new mechanism to carry metadata needs to have a well-defined method of handling types and versions that are not understood or supported by a receiving router. At the moment, I think you would just toss the packet. So we do need to understand exactly what we need to do as we expand these use cases. We need a mechanism to indicate the presence of metadata or actions on an MPLS packet. We therefore need an in-stack method to serve this purpose. Any in-stack method is in scope. Theory here is that it's expensive to go and have a look at the bottom of a deep stack, and so we'd rather not do it unless we know there is something of interest down there. One proposal is to repurpose an existing base special purpose label to serve this purpose. However, to do this, it must be shown that there is no potential interference with the current role of that bSPL. If we can't demonstrate the non-interference, then we should assign a specific forwarding action indicator based special purpose label. In other words, if we're going to break the existing applications that are associated with that bSPL, we can't enhance it to a new purpose. We would have to use a new SPL. Next slide, please. So one of the things that we've also concluded is that multiple actions may need to be indicated in the same bSPL. So remember, firstly, that we haven't got very many of them, so we have to conserve them. And in some ways, this is a bSPL conservation technique. But also, sometimes you may want to do several things when a packet arrives at a node. And so it's likely that we will need to indicate more than one action. The final statement, conclusion we came to, is that the coexistence of OAM mechanisms and auxiliary data encodings needs to be designed in the new mechanism. That is to say, we can't design a really cool data plane and forget that we need to have an OAM there. We have to do the OAM as a day one design. Next slide, please. So the work will continue. At least that's our proposal. We will discuss some of the issues that were raised here and some more issues in this session. We need input from the working groups on this work, and we really encourage those who are interested in this to participate in the meetings, which are currently at well, they're 4 o'clock UK on a Thursday at the moment. So any questions, please?
Hi, Stuart. Yeah. Hi.
Yeah.
My question is about the extended headers that we're thinking of getting in the ancillary data. Are they all going to be processed in the fast data path, or we think maybe some of them will be punted to the slow path for further processing, or both?
Well, I think all of the above. We have some that have to be done in the fast path. For example, no fast reroute would be a good example of one that you had to do in the fast path. Clearly, the actions that happen end to end, that will depend on whether they are a function that has to be addressed as this packet goes out, or whether they are something that can be addressed in parallel with the dispatch of the packet that's carrying it. For example, if we wanted to indicate some OAM action, then like record some OAM action, we could imagine doing that in parallel and punting the packet to the slow path. So it will depend, but there's a lot of functions that have to happen in the fast path to satisfy modern needs in networks. For example, latency control would have to happen in the fast path.
And Kriti is next. Kriti, go ahead.
I was at 6-man today, and there was a discussion on making the hop-by-hop option in 6-man in IPv6 work again, and not be just summarily dropped. And many of the discussions that they were having, and I mean, even the questions like the terminology of fast path and slow path, I think echo some of the things that we're doing here, including things like how much of this do you process in the fast path? Is it mandatory to do the whole thing? If you can't do the whole thing, do you drop the packet or do you forward it anyway? So I think it would be helpful, if only to align the terminology and some of the issues for a joint discussion with, I think it was Bob who was presenting that work, but I think it would be useful to align these two.
I agree.
Yeah, I'll just co-author on the relevant ones.
Loa, you're next. Go right ahead.
Can you hear me now?
Yes.
Okay. So one piece of information to what Stuart said. It was not the TEAS working group that was invited from the beginning. It was the Spring working group. It might have been a mistake not to invite TEAS, but it was a Spring working group, and they decided to stand off a bit.
Yeah, I apologize.
Yeah, many participants from Spring are actually taking part in the design team. Second, the list that Stuart listed as design team agreements reflect the agreement of a design team meeting, but it will also be sent out for a consensus call in the MPLS working group and actually copied to the other working groups, and I will include TEAS in that also. Okay.
Okay. Turles, you're next.
Yeah, so I was also in 6-man there, so roughly agree with what Kiriti was saying. I think the important part is to figure out all the different relevant cases for, slow path versus fast path. And I think the most important one is that we need to be able to say ignoring of all the things must be possible in fast path, right? You don't want to have nodes that don't even need and support that stuff, and then because it's in the packet, it's being punted. Yeah, we do know that we can try to avoid the problem with the control plane to a large extent, but that may require a lot more complexity than we want to. That was the mail comment as in 6-man.
Okay, very good. And let's go on to the next presentation. And Kiriti is going to be our next presenter. And if you wait 1 second, Kiriti, I will change the slides. Here we are.
Unmute, right?
And I can hear you. And
okay.
I will change the slides. So just say next slide.
Okay. Yeah. Next slide, please. So this draft started by we wanted to open the discussion into the use of the TC-TTL fields to increase the expressiveness of a base special purpose label. And potentially it could be used for extended special purpose labels as well. Right now, when we have a special purpose label, we only use the 20-bit field in the special purpose label, and if we have auxiliary data, that's only, again, 20 bits. And it's like, okay, we're wasting a third of our label, the entire label field, so let's actually use it. So by using it, the idea was that we could capture multiple forwarding actions with a single base special purpose label. And of course, the associated data can go from 20 bits to 31 bits. We did keep the end of stack bit sacrosanct because as you're parsing, you want to find the end of stack, and you don't want any confusion about that. And the other thing that we had done at the beginning that we kind of didn't go into was to allow for a dynamic or policy-based definition of the data fields. So instead of hard coding what the value is, we said, this could be determined by a policy. It could be something like a firewall policy. It could be other ways of distributing this information. But then if everyone agrees that the first 7 bits of a special purpose label or the label following a special purpose label has this meaning, then that could be determined by configuration rather than by standardization. However, that did lead to some issues that we decided to punt on, but during the course of the design team meetings, this idea came back up. So, but it was there in the original genesis of the draft. And of course, the bottom line of all this was to do this efficiently. Now, the thing to remember is when MPLS was defined 20 odd years ago, we really didn't, the forwarding engines were much more limited. Even the amount of space that they had to work with was much more limited. So the goal was to do this efficiently in today's forwarding pipelines. Next slide, please. So essentially what a base or a special purpose label base or otherwise does is indicate forwarding actions and sometimes associated data. So the forwarding actions, you have router alert or the no further fast reroute, which is still a draft, but they basically say, take the following action in the forwarding path, and the associated data, which is sometimes in the label stack, like the entropy label indicator or flow ID or the slice indicator, or sometimes it is after the label stack, the extended header indicator, the GAL label, GDF, or OM. So essentially the label acts as an indicator, and you have one base special purpose label that you burn for every one of these. And so the problem with that is we have a lot more ideas now. We have actually 6 in the pipeline, and we have 8 labels left, so we just burn all of them this way. So the forwarding actions indicator basically says, I'm just going to say that I have a bunch of forwarding actions, and then I'll set the flags to tell you which actions you should actually be taking, and also which associated data you have. So a single forwarding actions indicator can actually do multiple things. So the idea was to solve all these problems, as well as the problem defined in the next slide, which is, next slide, please. Which is the scarcity, which Stuart talked about, and it's a real issue. So 8 of the 16 base special purpose labels have been allocated. There is a way to have extended special purpose labels, but then you burn 2 labels for every one of those, and that ends up using a lot of label space. From a forwarding path point of view, it's not ideal. There are requests for 6 base special purpose labels of the 8 remaining. So the FAI proposal allows a single base special purpose label to capture 10 actions, and I say 10 because you have 11 bits from the TC, TTL fields. And if you use 1 for extension, because people have already said, oh, just only 10 actions per label is not enough, which fair enough. You can then say, I will use one of the bits to say the next label or the next 4-octet field has another 31 actions, of which again one could be an extension field. So you have 30 actions. If you go down that path, then yes, you have to burn a few more label fields, but you get a hell of a lot of actions encoded. And maybe we don't talk about scarcity anymore. And we may never have to use extended special purpose labels. Now, I know that there have been already 2 allocated, but essentially this would really solve the problem. Next slide, please. So as Stuart alluded to, there were 2 tracks in the design team, and we didn't quite stick to that, but we more or less did. One is what do we do within the label stack, and the other was what do we do after the end of stack. So you could call that payload, which is not really the payload from the customer point of view, but it is what comes after the label stack. This draft focuses on the label stack data, and the indicators are primarily for that, but there are also indicators for what comes in the payload. So we call that LSFAD and PLFAD, associated data, in the draft. And if the payload data is self-describing, then maybe you don't need to actually go into having a different indicator for each. You could just say there is data after the end of stack, and then you go find it and then parse it. There are, of course, other approaches. Next slide, please. So the 0.0 version had an opaque data field, which was about the semantics of the data was determined by policy, but wasn't elaborated in the draft. This topic came up, so we put it back in the 0.01 version. There was also an FA header for expansion of the flags, but it was not elaborated. Since both these issues were raised in the design team discussions, we brought it back in the 0.1 version. Next slide, please. So in the 0.1 version, we elaborate on the use of the FA header for expansion. So there's a single bit that says the next 4-octet field has 31 more bits. Presumably, one of them will be used for further extension, but so you get either 30 or 31 more actions that you could do. Also, after a discussion with Hao-Yu, I started describing when you should put data in the label stack itself versus in the payload. So for example, the ELI, of course, at that time, we didn't think a lot about this. We said we want the entropy label right there so we can make a forwarding decision on ECMP right when you see it. But then there are other things that may be similar. For example, a slice indicator is something you want to have right there so that you put the packet on the right path. But of course, not everything wants to be there. So a good example of that is the flow ID, which currently there's a draft by someone else who says, I want a flow ID in the packet, but it's more for OAM purposes. So I think there's a valid discussion. Should it be in the label stack or should it be in the payload? We moved some of the flags around in the 0.1 version to make space for what we call an end of stack distance, which is essentially a way, a slightly faster way to find the end of stack. There are only 4 bits, so depending on whether you count in 4-octet or 8-octet chunks, you can try to get to the end of stack faster, but you're not guaranteed to get to the end of stack. So you actually get to a label, and then you follow the end of stack bits until you find one which is 0, and then the next word is the end of stack. So this is a little bit different from what was proposed in Stuart's document, but has some of the same flavor. Also, the 01 version updates processing of the LSFAD and the examples. Next slide. So there are many discussion points. One is that the FAI must be processed efficiently in the data path. So a TLV structure, for example, would be very flexible, but it's not very efficient in terms of space and processing. So we use flags instead. There may be other approaches. The other thing that I think we haven't discussed, but we should be discussing, is seeing that this FAI actually accomplishes the task of 5 or 6 other FAI or SPLs. Should every SPL allocated by the MPLS working group going forward say, we are going to use the TC-TTL bits and we're going to make every future bSPL multi-purpose, and if we do that, we actually end up with a lot of space, a lot of actions that we can have. Even ESPLs can use this approach. The rationale of when to put data in the label stack versus in the payload, and you have to reach it. Even if you can reach it efficiently, it's still a little further away. And there's always the issue of how much of the header of the packet do you read into your forwarding engine so you can process it. So this is a lot of this depends on the forwarding engines you use and what is considered efficient in the data plane. So I think this rationale should be spelled out some more, and this is another thing that might be in common with what the 6-man work on hop-by-hop headers. There is the question of multiple FAIs in a label stack, so maybe an FAI per segment. There is whether we should actually use the edist, which is a 4-bit field, versus 4 more indicator flags and pointers. So label stacks are very large, so finding the end of stack efficiently is useful, but we have to figure out how to do that in the right way. Next slide. So the idea of flexible definition of forwarding actions has come up again and should be debated. There are issues if it is not standard. What happens if 2 adjacent routers or 2 routers in the path have different ideas of what's going on with the associated data? How do you change configuration across the network in a meaningful way? But the idea is a very attractive one, so I think it's worth debating it again and maybe solving some of these problems. So the issues are listed next. And then the other thing is that it's not mutually exclusive to have standard actions that, the FAI contains the entropy label and the GIST label. And by the way, it also contains more data, which is determined by policy. You can have both. So they're not mutually exclusive. Another thing I should say is the idea of indicators in the FAI and pointers are also not mutually exclusive. Offline, I was thinking of ways where we can put the 2 ideas together. It isn't in the draft right now, nor has it been discussed, but at the next MPLS design team, we might bring up this subject. Next slide. I think that might be the last slide.
That was the last slide, actually.
Slide. Yes. Okay.
And we have one question from Torlis, and I would like to end the queue just with Torlis because we are a bit behind time now. So Torlis?
Yes. Right. So in 6-man, there was also one draft they discussed, which was kind of a generic next generation router alert, also programmable, right? So maybe the discussion point 2 about the programmability of the semantic of these things, together with the equivalent idea from 6-man, is something to be brought up in LSR or routing working group to ask for, do you folks feel we can have an appropriately strong, consistency model from the control plane to do this, right? Because the other points I'm really not that much worried about.
Sure, and there was a vigorous debate on forwarding, on router alert, but we should definitely have that. Thanks. I'm done.
Okay, thank you very much, Kariti. And let me change the slides to Stuart. If you wait 1 second. Okay, Stuart, take the floor.
Right, so next slide, please. So what we're talking about here is a specific solution for using pointers and showing how they add value to the design of packets. Pointers allow specific rather than implicit data or actions to be located, and they allow an association or direction as to what data carried in the packet you want to use in processing a hop. There is a draft that's being presented in RGWG that gives you a much more complete idea of where this could go, and describes quite a powerful sort of language, if you like, for packet design. So it's an advert for that. Next slide, please. So certain use cases benefit from auxiliary data being part of the forwarding decision. So what we need to do is to figure out a way of doing this that's suitable for high-speed forwarding, works with existing hardware, and is backwards compatible in terms of forwarding with legacy hardware. Next slide, please. So the approaches so far that have been looked at are rely on the forwarder finding out if there is any applicable auxiliary data below the bottom stack and deducing which of that auxiliary data needs to be applied at this hop. And we already do this, for example, when we sneak a look at the transport fields, for example, for load balancing. Some methods make it easier to deduce if there is data, but not where the data is. None of the proposed methods really deal well with the case of auxiliary data that is different at different hops. So the approach that we're describing here builds on the draft that Kariti proposed at the last IETF meeting, but instead of using the TOS and TTL bits as pointers and stuff, as regular indicators, we're going to use them as pointers. Next slide, please. I'm going to propose using it as that. So the core idea is to use some spare bits in inverted commas in a non-top of stack field as a pointer to the specific ancillary data that is to be used at this hop. So the semantic is forward according to the top label L1 using the assistance of the information pointed at by the pointer label L2. So it forwards was normally when L2 is not a pointer, so you're not requiring that a pointer follows the top of stack. So it's a normal MPLS label stack most of the time, but if we wish to insert a pointer, we can do so, and that pointer directs us to specific content of interest. Next slide, please. So the advantage is that we have the ability to find which auxiliary data is important to us without reading the whole of the stack. Indeed, we know whether we want to look at the bottom of the stack, and we know specifically where. It has the ability to specify which ancillary data is applicable to a particular forwarding label. It simplifies the packet parser as there are no deductions or discretion needed in how it's going to operate, and it's inherently general and extensible. Next slide, please. So our assumption to start with is that the pointer will be a special purpose label of some sort, but we could make the top of stack indicator we could make the top of stack indicator pointer, but that means we need to change the FEC of the top of stack label. In other words, to say we could change the FEC, which is what we did with the RFC that records the time spent at a node, but that's not really doesn't really have the degree of legacy compatibility we'd like. And in any case, we would need more labels in the global label table, because we have to deal with the case that we want to use a pointer, and the case where we don't. Next slide, please. So here's a case. Label 1 needs pointer at L2. Label 2, which will later on become the top of stack, needs the pointer at L4, and they both point to the same auxiliary data. So you can see the stack when we start and the stack when we pop, L1 and L2 as a pair, it's not particularly efficient. Next slide, please. So what we could do is to regard the top of stack and pointer as essentially as a pair. That is to say, we can encode by some means or other that we need to carry the pointer forward for use with L3. It's a different swap operator, but we're going to have to change a few things anyway in order to do any of this ancillary data inclusion in the forwarding decision. When you move the pointer, of course, you're going to have to do a correction, but that's only subtract 4 bytes from the pointer. There is, of course, a problem, which is how do we know when to stop propagating the pointer? Do we do this with some sort of TTL in the pointer? Do we do this with a bit in label 3 that says whether to propagate or not? Do we do it with the FEC of a label 3? I guess I'd rather not. Or do we point to a piece of auxiliary data which says what we are to, when we're to pop the SPL? Next slide, please. Now, clearly we can extend our thinking further and have multiple pointers. So the semantics now becomes forward according to L1 using the information in pointer 1 and pointer 2. It's an obvious extension to the concept. Next slide, please. And of course, you'll notice that we can do this in groups. So pointer 1 is only used once, but pointer 2 is used twice because there are occasions where multiple hops need to point to the same piece of ancillary data to do their job. Latency-based forwarding is a good example of that. Next slide, please. Now, when we presented this in the design team, the first one of the issues that came up was, what do you do about ancillary data that needs to grow? An example of this is one of the classes of IOAM. So our thought is that you're going to have to always shift the stack up and put the increased data in with any sort of growing ancillary data. But what we can do is we can take some learnings from the way that disk operating systems work and put the expansion space, insert that into the ancillary data block after the existing ancillary data, and have a pointer from the block that's expanded to the expansion block. We can do this as many times as we need. So we can learn from the way that disks operate and expand ancillary data if that is needed for certain types of, well, usually OAM operation. Next slide, please. Something that's important to understand with all of these techniques is the need to describe the disposition of the ancillary data. So once the ancillary data, once the packet has got to the edge of the network, we need to remove the ancillary data. And this can be a lot more complicated than just simply dispose of n bytes. And there are a number of techniques that we've explored for finding the disposition data. We can follow the same technique as we do in pseudowire, which kind of says, what follows the bottom of a stack. We can have an SPL at the bottom of a stack, a bit like a gal, to say what to do. But the most powerful thing to do is to make the bottom of stack LSE point to auxiliary data that describes the disposition. This is much more powerful than any of the implicit methods that we've used in the past. Next slide, please. This is just a trivial sort of concept of how it would work, and if you've studied the work that Kiriti has proposed, you would understand this. Next slide, please. So this is a short note that SPLs are in short supply. This is a heretical note, really, I suppose. ESPLs take twice the stack space. I was wondering whether we couldn't use a regular label as a pointer. So I'm not talking about global labels in the way that the MPLS segment routing people were. I'm talking about needing a small number of labels which we agree to use network-wide for this. So we take some labels out of the regular global pool and we assign them to this purpose. They don't need to be a common label block in the sense that SR needed it, because it doesn't matter whether they can appear in the fib or not. If they can appear in the fib, then you just need to pre-allocate them. If they can't appear in the fib, then these are special labels that are handled by the forwarder, and so the forwarder would handle them in its own way according to this forwarding semantic. So we could special case a few of the normal global labels and significantly expand the number of special purpose quotes labels in the network. Next slide, please. So questions, please.
And I see Kiriti.
Good. Thanks for the presentation. So a couple of questions. One is effectively, and you've kind of said this, you're burning a special purpose label if you use special purpose labels for a particular type of auxiliary data or ancillary data that you point to. So that label basically says, if you follow the pointer, the data that you get has this semantic. And I think the value of trying to get multiple uses out of a special purpose label using this the TC bits, and say the next label says I have maybe 4 pointers, depending on how many pointers we can squeeze into it, and those 4 pointers have this meaning. So I think that there's a way to combine the use of, use the TC-TTL bits to indicate what the actions are, to indicate essentially the semantics of these pointers, and then actually, follow the pointers to get to the data that you need to get to. So that's one point.
And be delighted to spend time discussing that with you, Kiriti. I'm not precious about the design. What I'm quite intrigued with is that you can do some very powerful constructs if you point to things rather than imply that they're there, that they're somewhere.
Well, yeah, so that's the other part of what I was going to say is there is this section that I put in the 01 version of my draft, which is when do you put data right there where you need it, and when do you put data that you point to, which you can point to at the end of stack or beyond the end of stack. And I think that's another discussion that is worth having from the point of view of, when we did the entropy label. I mean, when we did GAL, we said, okay, we didn't have a pointer, but you just look for the end of stack, and then beyond that, you're going to have this associated channel, and then go do your stuff there. But with the entropy label, we said we have to have that right there. So at the point that forward is trying to make a decision, it's there. So I think there are some things that you want in the label stack, you want at your fingertips, so to speak. It's almost like if you continue your discussion or analogy of the disk, it's like that cache that you have that's right there, and then you point to the disk, and then that's where the longer term storage is. So I think that's another thing that needs to be fleshed out some more. And then the last thing I would say is that label stacks are getting very big. So I think we have to talk to a few people. That's why we had someone from Broadcom Israel, who was a co-author, because we wanted to discuss what would it mean for a forwarding engine like what Broadcom builds. We know we have our own ASIC team, so we can tell you that. But we want to get sort of a wider experience of what ASICs can do, what is easy, what is hard. And that's why I say there's some overlap with 6-man, trying to define what's the right way of processing this stuff and how much of it you process. But yeah, I think there's definitely good things on both sides, and we should continue this discussion.
Okay, very
Thanks.
good.
Thank you for those comments.
We have to keep the queue going. I'm going to cut the queue off after Tariq so we can move on. But Tariq?
Yeah, hi. Quick question. Normally, extended headers are processed sequentially. Are the way you describe them, Stuart, as if we are processing one extended header in singleton. Do we need to design it, in our encoding such that we don't process the headers sequentially? Is that what you're thinking?
Yes, I mean, you see, there are some cases, and the other draft I pointed to really does go down into exploring some of these cases in a lot more depth, but it's not an MPLS design. There are some cases where you want to skip over a piece of data to process. There are some cases where you want to share a specific piece of data, but only on some hops. I think we need to look at the application and then decide what makes sense in terms of laying out the auxiliary data, and then get the stack to indicate which pieces we need to process on a particular hop. I mean, some hops you may not want to do everything.
Okay, very good. Let's move on to Hayu. Let me change the slides. And Hayu is going to be pulling off a great trick. Let me see. I'm not seeing his slides, so let me start it again. Nope, that's not. Wait 1 second. Let me try it again. There we go. And Hayu's going to pull off a great trick. He's discussing 4 different drafts in one set of slides. So take it away, Hayu.
Yes, thanks, Andy. Just to save time, I just combined, 2 slots to present this MPLS extension header idea. It's actually include 4 cohesive related drafts. Next slide, please. Yeah, first, I'd like to thank our co-authors, Robin, Tianran, Loa, Jerry, Jim, Stuart, and some contributors, Kiriti, Bruno, and Andy. Also, we'd like to thank all the chairs and attendees in the MPLS OpenDT weekly meeting. There are a lot of fruitful discussions to help us to improve the drafts. And in the following slides, you will notice some texts are labeled in red color. Those reflects the newly updates to those drafts. Next slide, please. Yeah, first, let me recap some motivation for this work. So we observe there's some new in-network services over user packets emerge. For example, the in-situ OAM, network slicing, service function chaining, beer, segment routing, and network security, and network telemetry. All of these need to add some special metadata or instruction to the packet header. And when you think of them in a piecemeal method, some of them will claim, okay, we can stack this data just between the label stack and the original payload. But soon we will find, in many cases, we might want to support multiple such applications in one packet. Then they will compete for the same resource. Also, each of them will require maybe a new label, special label to indicate it. That will become very inefficient. Also, we want to make this really flexible. On the label switch path, any node is able to add, process, and remove some instruction header or metadata. So in this very flexible configuration, we have to have some mechanism to support that. So that's why we think about how we can do this efficiently in MPLS. We come up with the idea of an extension header. Next slide, please. So the solution is that we should stop design any piecemeal and incompatible solutions which compete for the same resource, like the special purpose label and the location after the label stack. Instead, we should have a generic framework once for all. So basically, we can put all the instruction headers or metadatas as extension headers, and we chain them together and put them between the MPLS label stack and the payload. This concept is very similar to IPv6 extension header, but we should be aware there are many issues about IPv6 extension header and some lessons we need to learn. For example, for IPv6, only end hosts are allowed to add and remove extension headers. But here, actually, we do that only in networks. And in IPv6, only one hop-by-hop header is allowed. And if you want to support multiple actions, you have to use multiple HBH options in that header using the TLV structure. That's inefficient. And also for IPv6, if you want to access the original upper layer header, you need to scan through all the extension headers. So that's also very inefficient. Next slide. So for us, we need to meet multiple requirements. The first one is the flexibility. In this figure, you can see we have a single label switch path. There are some nodes are extension header capable, like the A, D, F, and G, and some other nodes are extension header incapable. And we can build multiple extension header paths on this label switch path. They can start and end at any node. Of course, those nodes starting point and ending point must be extension header capable. So this kind of flexibility need to be supported. And also extensibility. Right now, we have already seen several use cases, but eventually we can expect there will be more use cases emerge. And third, we need to care about the performance, because this is for the on-path processing. So it's very important to guarantee all the user packets can be efficiently forwarded. And last, the backward compatibility is also need to be considered. Next slide, please. So first, let's talk about how to indicate the presence of extension headers. In one of our draft, we list several possible solutions. The first set of solutions is using the dedicated labels, like the special purpose label or extended special purpose label. The second set of solutions is just to extend the generic ACH mechanism, like use a GIL to indicate extension header, and maybe we have some special encoding to put the extension header in the ACH. And the third kind of solution is to overload the new semantics to some existing special purpose labels. For example, we can put it into the entropy label indicator. The last possible solution is without using any special purpose label. Instead, we just use a control plane configuration to configure the FAC labels. to indicate their extension header in the packet. And based on the past OpenDT discussion, we have decided to not go to the GALE and GSH path. And for us, use a single special purpose label is preferred. And also, there are proposals have been made, like the FAI, to overload the indicator with some other forwarding functions. Next slide. Yeah, so in these slides, we show some a proposal to how to encode this extension header indicator special purpose label. So the first part, the label part, is just need to claim a new special purpose label number. And the TOS field, we are redefined to them to be some flag field. For example, we can define the first bit as a H flag. H flag simply means there are HBH extension headers in the payload. So it can be used to help some and EHP end nodes to avoid unnecessary extension header checking, because if they see they are internal nodes, they just stop searching anymore. And also the EH off size can be used to provide the offset of the header of the extension, the first word of the extension header part. So this is only useful if the extension header is not at the bottom of stack. And also we could use fewer bits as offset to save some other bits, for some other functions. Next slide. Okay, then below the bottom stack will be the MPLS extension header part. So the extension header will start with because there are multiple extension headers stacked together, and so each extension header will indicate the length of itself and also the type of the next extension header. So essentially, all the extension headers are form a chain, just like the IPv6 extension header. And we suggest to adopt the same the standard Internet protocol numbers as an extension header tab. But for better extensibility, an extension header could have subtypes, so which can be specified in a subfield of the extension header. And we also need to support 3 special next header types. The first one is none, which means there's no next extension header and the payload. After the current extension header, we reach the end of the packet. So this is used for special packets like some probing packets. The second special type is unknown. It can be only used in the last extension header in the chain, indicates the payload type is unknown. And the third type we recently added is MPLS tab, which means there will be another MPLS label stack follows this extension header. So this is interesting because in some use case, we might have multiple MPLS stack sections. And for example, for the StudioWire application on top of another MPLS infrastructure. And for some other tunnel-in-tunnel use cases, so we can have a multiple section of MPLS labels separated by the extension headers. And also, we need to support the case where the GALE and the ACH are present in the packet. So if there are ACH in the packet, then the extension headers will be located immediately after the ACH header field. And we allow all the extension headers to be jumped in just one step. So that's why in the header of the extension header, we define the total length of the extension header. So if we want to access the original upper layer header, we can jump to that section immediately. And also, we want to support both end-to-end type or hop-by-hop types. And for the efficiency, we require to put the end-to-end extension headers behind the HBH extension headers. Next slide. So these slides show the details of the MPLS extension header format. So the top section is MPLS label stack. In it, somewhere, we have this extension header indicator. Then follow the label stack. You can see there's a word for header of extension. The first 4 bits are reserved. Then the next 4 bits is extension header counter to indicate how many extension headers we have in this packet. So which means also we can have up to 15 extension headers in the packet allowed. Then after that is extension header total length. So this can be used to skip all the extension headers to reach the upper layer. Then follow that, we have an original upper layer protocol type field. It's labeled in red. So which can tell, okay, what's the type of the upper layer protocol. And then we have a type for the next header. Follow this header of extension header, HEH. We just have a chain of extension headers. For each extension header, it starts from the next header type and the current header length. So you can see there's also a possible optional field. It's a subtype extension. So it just which can be used to extend the extension header types. And with this configuration, we can allow the total length of the extension header to be 1K byte. And also, we can support the case there's 0 extension headers and only the header of extension header exists. So with this, it can be used to tell what's the type of the upper layer protocol. Next slide, please. We also have ways to optimize the forwarding performance using FEC labels. Because right now, if we don't have any other method to, we have to scan through the entire label stack to find the extension header indicator. So if it's below the TOS, the top of stack, there could be some performance impact. And so to solve this problem, when it's establishing the label switch paths, we will assign 2 FEC labels. And one is means, okay, this just forwarding the packet, there could be extension headers. You need to search for it if you are extension header capable. But another means there's no extension header in the packet. It's explicitly to tell that the fact. So for the E8 extension header incapable nodes, they just do the regular forwarding. But there are extension header capable nodes. If they receive a regular label, so they will need to examine if there are extension header in the packet or not. So if yes, they will use if there's a extension header in it, they will continue use a regular label to forward the packet. If it finds there's no extension header, they will switch to the no extension header fact label to forward the packet. And for the EH capable nodes, if they receive a no extension header label, it will know, okay, there's no extension header in it, and if it also doesn't add any new label, a new header to the packet, it just needs to forward this packet with a no EH FEC label. If this node inserts some new extension header to the packet, of course, it will switch to the regular label to forward the packet. So this way, we can, in many cases, we can improve the forwarding performance without actually needing to search for the extension header. Next slide. So summary, we think the extension header is a generic solution for MPLS in-network services. It's built on common industry practices and keep performance, flexibility, and extensibility in mind. And we also believe extension header is especially compelling for MPLS because MPLS label stack, the overhead is much smaller than IPv6. And MPLS is also protocol independent. We can use it to actually encapsulate any other protocols. And the good thing for us is also we don't have too much history burden like than IPv6. Therefore, we have a lot of room for new innovations. So just let's keep it rolling. Thank you very much.
Okay, very good. I see one person in the queue. Jagan Babu, take it away.
Yeah, this is the concept wise is very, very good, but what I feel is that implementing in the hardware will be pretty complex, and also if you do that, then we might need to change all the routers if you want to support any new features which needs this kind of enhancement.
Yes. So in terms of the packet parsing, it's no more difficult than the current practice. But yes, with any added extension header, you need some more packet processing. So therefore, I believe in most cases you will control how many extension headers allowed in the same packet.
Okay, shall we? Go ahead.
Yeah. So when this proposal was discussed at the very beginning, my impression was that there were concerns about the header of extension itself. Since I missed some design team meetings, I'm just curious if there were any follow-up discussion on that, and if it is if we already have consensus to keep that header extension or not to use the header extension.
Excuse me. Yeah, you sound a little bit broken. I can't hear you clearly. Can you just rephrase your question in one sentence?
Okay. So at the very beginning, I think there were people who do not like the head of extension header.
Okay.
Since I missed some meetings, I just don't know if that was discussed further, and if we already have the consensus to keep the header of extension header.
So I don't remember we have further discussion on that, but the point of the header of extension header is to use to summarize, some information about the extension header to help us to reach the upper layer easily. Because there's no more space, I think, in the label stack to provide the same amount of information. So that's why we started start the extension header section with another header, is one word header. So that's the purpose of it. So I think it's still open for discussion, of course.
Yeah. And I just want to remind everybody that any decisions that are taken in the design team will have to be ratified by the MPLS working group as a whole. Okay, and we have Greg Mirsky next. Greg?
So, am I understanding correct that the proposed headers are immediately follow the label stack?
Yes, in most cases, yeah.
Okay. Have you considered how it works if there is a GAL label in the label stack? or
Yeah,
label
actually,
GEL label cannot be used.
yeah, and it can be used. I actually covered that in the slides. I said if there is a GEL label and the ACH, the extension header will follow ACH.
Yeah, that's covered in the draft as well. We have one more person, Tariq, and then I would like to cut off the queue there. So Tariq.
Okay, quickly, a packet may arrive with extended header on a router, and that router wants to add or insert extended headers. It's not clear to me how you can insert extended headers in that case, and how do you pop, those extended headers at different egresses. So
Yeah, it's easy to add a new header into a chain, right? You just find the right location, then you modify the previous header's next header field, and you put it after this header, and the chain also set its next header to the value of the next header type. So that's it. For deletion, you can do the similar thing. You just need to modify some field in the previous extension header.
Okay, Stuart, can you make it quick?
Yeah, I just wanted to clarify a point that how you were saying that you could put an extension header after the ACH. There is no length mechanism in the ACH at the moment, so existing ACHs can't have extension headers after them. You wouldn't find them.
Okay, thanks.
Yeah.
Thank you, Hao-Yu, and
yeah. Okay.
Let's move on to Jeffrey. So let me quickly change the slides. And Jeffrey, take it away.
Okay, thank you. So this is an update on the generic delivery function, in particular to use MPLS or beer extension headers. Next slide, please. This generic delivery function was presented in last IETF meeting. To recap, some IP functions can be viewed as to be independent of IP. For example, fragmentation, ESP, or IOAM. So what if we extract them out and apply to any layer where it makes sense? For example, IP, MPLS, beer, or even Ethernet. So we call this generic delivery functions. It's basically between any 2 points at a layer 2, layer 3, layer 2.5. For example, between 2 Ethernet nodes, between LSP ingress, egress, IP source destination nodes, things like that. Next slide, please. So in the earlier revisions of the drafts, we have the proposed this header for generic delivery functions. I'm talking about it here just as FYI because we are actually thinking of changing that. Anyway, you can see that here we have a next header and then this header. Next header will come from the IP protocol number space. It could point to another GDF header or IP next header. And this header uses its own number space for different GDFs. With that, let's say we have multiple GDF to support. That way, we don't need to take one number from IP protocol number space for each GDF. That was the intention. And the outer header, for example, MPLS label or beer protocol field, the IP next header, will indicate that GDF which follows. Next slide, please. So as the MPLS design team in this discussion going on, and also a better understanding of the MPLS extension headers, and now we have some new thoughts about on how to encode the GDFs, GDF headers. So a GDF being generic, that means it's likely to be applicable to IP as well. So therefore, there's really no need to have this header to indicate what it is. We can just use certain IP extension headers at other layers. If we need to make small enhancements, we can do that. For example, fragmentation. We can just use the existing IPv6 fragmentation header with some extensions that I will talk about later. So we do not need to have IP next header code point to indicate that the next header is a GDF either, unless in the future we run into some so-called GDFs, but they are truly not applicable to IP. In that case, if we want to save a number from the IP protocol number space, then we can have a GDF type, and then we have subtypes to indicate what kind of GDF it is. So if we do that, then the MPLS label stack or beer header will need a way to point to an IP extension header. So as you have seen from Haoyu's presentation, MPLS header extension head of extension header serves that purpose. And beer will need something similar or something simpler. Next slide, please. So if I use MPLS extension header for to do fragmentation and reassembly, you can see that we would use MPLS head of extension header. It will in that HEH, the next header will be value, I believe it's 44, to say that a fragmentation header follows. And you can see that on the right side of the slides, that is basically the existing IPv6 fragmentation header with some enhancements indicated by the red color. The enhancement is needed because in case of IP or IPv6, the source and destination address are used together with the identification, and to know that which fragments are together, because identification number itself could be the same for different packets from different nodes. So we need to use the source and destination address as the context. Now with MPLS, we do not have that anymore. So we would need to encode the sender information in as part of the identification. To indicate that, we use S bits to indicate that the sender information is included. And because when you use this fragmentation for different layers, the sender information may have different lengths. So now we actually need to encode the header length there. That in the IPv6 fragmentation case, the header length field is actually reserved; it's not used. But here we actually use that field to indicate the length of that header. So that's the example of the fragmentation. Obviously, other generic functions like the ESP and AH, and also in situ OEM can also be done similarly using the MPLS extension header. Next slide, please. So even though this is not a beer session, I thought I'll talk about it quickly. So beer is another forwarding plane for multicast, and each beer packet carries a beer header. So as in the part of in the beer header, there is a protocol field. We would assign a new code point for that protocol field to indicate there is an extension header that follows. And so when the protocol field is set to that protocol set to that code point, it means that after the regular beer header, there is this extension header following. That we can either start with something like the MPLS header of extension header, or we can simply just need the 8-bit number to indicate what that next header is. So it depends on the discussion and whether we really want the HEH or not. That's why I was asking the question earlier. So then after that, you can see that the purple color is the IP extension header used for fragmentation. And here we don't even need that sender information here, because in the beer case, that BFIR fields after the protocol field can be used to identify sender, and that together with identification can be used for a fragmentation and reassembly purpose. And next slide, please. So we have not got a chance to update the corresponding our drafts, because this the news source came very recent after or more discussions on the MPLS extension header. But so we seek more comments, and then we will update the drafts accordingly. So that's end of the presentation.
Okay, thank you very much, Jeffrey. And just before I give the floor to Karidi, because I see he's in the queue, that was the end of our last formal presentation. So now we have about 25 minutes by my watch for open discussion. So the floor is open to everybody for whatever you'd like to talk about as a result of all these presentations. So with that, I'll give the floor to Karidi.
Andy, my question for Jeffrey is, it's, I think, a really intriguing idea to use common formats, especially data plane formats, between, say, IPv6 and MPLS and beer. And the value of that is, if I'm writing microcode for the forwarding plane, maybe, you know, if I can find a way of doing it in a more modular fashion, then I can say, plug in this microcode. You know, I'm going to parse the header. Oh, this is IPv6, but I'm going to call this microcode as a subroutine. Oh, it's MPLS. It doesn't matter. I'll still call this thing as a subroutine. Maybe there'll be a few tweaks because a few fields move around. So I guess the question is, does that actually play out in real life? I mean, have you talked to anyone in the forwarding path to see if we can actually do that kind of reuse of microcode?
I have actually not got the chance to check, but my thinking is that it just makes sense to do that. I would be really surprised that it's not done that way.
Yeah, we should dig a little more into it, and maybe others can do the same.
Yes.
Thanks. Yeah.
Okay, very good. And Tariq is next.
My question is not necessarily to Jeffrey, but to the design team. We have seen so far maybe three different encodings of metadata after the end of stack, MPLS end of stack. And my question is, how do we want to? We definitely want to pick eventually one encoding to standardize. And do you think we should, evaluate the advantages, disadvantages of each encoding, and come back and evaluate which one is the best? Is that the way we should proceed?
And who would like to answer that? Stuart, would you like to answer that?
Speaking now, yes. So a proposal I made to the design team a little while ago was that we really need to understand the applications. Any solution really should be generic, etc. But understanding what we're trying to do is always a good way of sort of focusing the design. So I think we need to understand what we're going to do with this, and then it'll be more obvious which one we should pick. I do have another comment, but I'll do that when after Greg.
Okay, so Greg, you're next.
So first, Stuart, thank you. I appreciate your comment earlier about ACH. And that's my question to, and actually in continuation what Tarek suggested. So should we have a list of requirements, and would their backward compatibility with ACH be one of the requirements for any potential encapsulation scheme? Thank you.
I saw that Jeffrey would probably like to answer that.
Okay.
Jeffrey, are you speaking? We can't hear you.
Speaking muted. So about the coexistence of ACH and the extension header, the design team concluded that we wanted to support that, and my understanding is that ACH we will know when the ACH ends, right? So as long as we have phi in the label state step to indicate there is an extension header, and then we also know that there is a ACH because of the existence of gal, then we should be able to find out at the beginning of the extension header, which is basically right after the ACH.
My understanding of ACH is that it is only known if this ACH is supported. So there is no explicit indication of the length of ACH. And for example, residence time measurement that includes PTP messages. So parsing it only possible if the node supports this type of ACH.
Absolutely correct, Greg. That's a point I made in an intervention earlier on.
Yeah,
there is nothing in current ACH.
And again, in my understanding, for example, if I don't want to compare, but the scheme that Stuart proposed to me appears that it can easily support or coexist with ACH.
Yes, I believe it could, because it points directly to the information you want to use. You don't need to. Now, when you pull the thing apart, you're going to have to figure out how to pull it apart. But
yes, that's my understanding.
Is always,
but again, I just don't want to extensively discuss this point, but just to have this as a requirement, and when we get to evaluate different proposals, understand what ACH currently is and how it's been defined and how it's been used. So not all nodes support all ACH.
Correct.
Okay, thanks,
So-
Jeff.
So I would like to raise a different point from the floor, which is that one of the things that made MPLS so incredibly successful was its simplicity. And when I look at some of the proposals, I fear that we have lost sight of that cardinal principle in the design of MPLS, that it should be simple and that the control plane should take an important role in interpreting what the actions are. So please, let's try to have a simple design that goes fast and is not sort of buried in complexity.
Okay, and Karidi is next in the queue.
Thanks, Andy. I want to go back to the ACH question. I dropped a comment in the chat that maybe we should put that to bed. The idea that you have, a header or some data that you don't really know where it ends. You don't have a length field. I think that makes things harder. I think Stuart was agreeing that it's not the data that we want to throw away, but maybe the encoding of it and the way that you actually deal with this. I think we might, if we come up with a comprehensive way of encoding data after the bottom of stack, then we can fold ACH into that and then sort of deprecate at least the gal label and the current way of doing ACH, and carry the useful parts of that in a way that's compatible with how we're going to do stuff after the end of stack. Thanks.
Okay, thanks. And Jeffrey is next.
Okay, I want to make 3 points. I hope I remember that those 3 points. About again for the coexistence of ACH and extension header. If we say that we are going to not allow the coexistence, or if we are going to say that we will just implement the ACH function as using extension header, then yeah, we solve the problem that way. But if we do to allow coexistence, and now that I know that there is no length in the ACH header, then I realized that how you actually talk about that for the indication of the existing extension header, at that part we can actually provide an offset, right? So that's one way to find out where the extension header exists, starts when we also have the ACH. So that's the first point I want to make. The second point about complexity. I guess if we have a requirement, then we want to support it. But I guess the definition of complexity is complex. Is the pointer solution a complex solution? I guess that's also subject to discussion. The third point is I kind of forgot. I guess I'll drop it for now. Table it.
Okay, very good. Thanks. And Jeff, you're next.
In line with what Kirati said, being backwards compatible comes at price, and specifically to GalGatch, price is rather high given the semantics. So, and in all my years in the industry, I've never seen it actually deployed. So I'm not maybe representative here, but we really need to do proper analysis how much it is needed, try to move it into more generic function, or potentially just put it to bed. I mean, if it's not very much deployed in use, making new solution backwards compatible brings price and complexities that's not justifiable.
Okay, thanks. Greg?
Well, definitely in one geographical area, ACH is deployed broadly and supported. Whether it's sufficient for us to consider or ensure the backward compatibility, that's a different question. But at the same time, so it's been designed, I don't think that it's possible to really get reliable information of what's being deployed and say, oh, nothing is sufficient scale being deployed elsewhere of the geographical area we know about, so that we can ignore it. Again, I would rather keep it as a requirement. Thank you.
Okay, thanks. Stuart, you're next.
No, I'm going to dispute the idea that the ACH is not widely deployed. I believe it is quite widely deployed in pseudowires, which is where it was designed for. And the tendency has been to move to that as the OAM technique, deprecating some of the earlier techniques, at least as I understand it. I'm prepared to be told I'm wrong.
Okay, thanks. Jeffrey?
Now I remember my third point. So the coexistence of ACH and the new extension header, also and also the backwards compatibility. My understanding is that if you have a router that only understands ACH, and then there is also a extension header following it, I don't think that causes a backward compatibility issue, because the legacy node will just process the ACH, which is right after the bottom of the stack label, as before, and it just doesn't process the extension headers. And by design, that's fine, because extension headers are new functionality. If your router that the node does not support it, then what can you do? It does not support it, right? So it's not a issue specific to the coexistence of the ACH and extension header.
Okay, very good. Kuriti?
What I said about ACH, the idea, and I'm not talking about how well it's deployed or how much it's deployed. It's really about when we redesign, as the design team is doing, at least one track of the design team, the stuff that goes below bottom of stack, instead of trying to coexist with the current definition of ACH, the idea is that it incorporates the ACH information in a way that makes everything much more extensible. And so we don't tie our hands trying to incorporate ACH the way it exists today, but we incorporate the information that ACH carries in a way that makes the overall architecture simpler. And that's basically the thing that we need to do, I think, rather than actually throwing it out, which is, I think, the wrong thing to do, or trying to coexist with it as it lives today. If there is a way to coexist without making without restricting ourselves, limiting what we can do, and making it very complex, okay, that's fine. But if there isn't, we take the ACH information and wrap it into the architecture for whatever comes after the bottom of stack. There's a similar discussion happening with 6man on router alert, and part of what they're trying to do, as Adrian put it in that meeting, they would dance around the issue of router alert when they're defining or trying to redefine how to do hop by hop. And one of the discussion points there is, no, just forget router alert. In that case, I think you can actually do away with router alert. But in this case, I think we have to re-encode ACH so it fits into other new architectures. Thanks.
Okay, and Stuart?
Take this in a number of phases, right? So we can't break LSPs or pseudo wires that are running across the network that happen to be using ACH at the moment, right? So in terms of discard and compatibility, etc., we can't break those. They have to be able to still live in the network. In terms of whether you can put an ACH and an extension header in the same pack of some sort in the same packet, then I'm going to dispute what I think was Jeffrey said, because when it comes to disposition, you've got to know that it's there. So if you get into a legacy node that discovers an ACH, processes that, and then there is an extension header afterwards, there's a big danger that that information is going to get passed and parsed as payload to some poor unsuspecting next hop. So we can't, you can't just hand wave over the existence of both. The disposing router has got to know how to get rid of everything that sits between the bottom of stack and the real payload to be delivered. So, and finally, I kind of agree with what Kariti is saying, though, which is that in cases where we want to use an OAM mechanism of the sort that ACH provides, and we want to do something new, we probably need to migrate the OAM information into a format that's compatible with our new ancillary data structure and system. So thank you.
Okay, great. Just before I give the floor to Jeffrey, I'd like to point out that we have about 3 minutes left for discussion, after which Stuart's going to take about 5 minutes to close us out. So, Jeffrey?
Okay, I just want to clarify that the compatibility issue is not specific to the coexistence of ACH and extension header. It's the extension header itself support even without the ACH in the picture. We have to be careful that what if LSP egress receives a packet with extension header, but it does not know how to deal with it. That's a general backwards compatibility issue.
Okay, great. Is there anyone else who wants to join the queue? Now is your last chance. Going once, going twice. Okay, Stuart, the floor is yours to take us out.
Right. Okay. Well, I will attempt to summarize what I think are the key takeaways from this. First is that we should probably extend an invitation to the TEAS working group. Lou is at liberty to say no, we don't need to, but I think we should probably extend and you should note to the members of the TEAS working group that we exist and are doing this work. There's clearly a tie-in with the work that Sixman are doing on hop-by-hop headers. There's some mutual learning, not necessarily the same solution, same technical solution, but some mutual learning to be done. And I think it would be useful to have a joint session with them. A number of these proposals could usefully be merged. Certainly the work that Kariti's done and the work that the people I've been working with have done could be usefully merged. We need to see how we can merge with the AD, more complex approaches for describing the data, the ancillary data definitions. I don't know what synergy there is there, and that is something that the design team needs to actively work on. And finally, it's quite clear from this discussion that there's a lot of ACH coexistence matters that are still unresolved, and some quality time will need to be spent by the design team working on that and trying to find a way of finally resolving that. I'm not sure whether I missed anything else that any of the other chairs want to say, so I'll put it over to them to add their comments.
Okay, anyone else like to speak before I end things? I'll wait for 1 second here. I don't see anyone else joining the queue. So I put up the meeting online resources slide again. I especially want to point you again to the MPLS Open Design Team Wiki, which is the URL starting with track.ietf.org. Everything going on in the design team can be found there. Design team meetings will be continuing, as we said. So, and the announcements for the design team will be made on the MPLS email list. So monitor the MPLS email list, and it looks like Loa has something he'd like to say. So Loa, go ahead.
Yeah, just about the wiki, everything is there, but the structure is not very good. So if you go look at it and can't find things, ask myself or any other of the MPLS working group chairs or some other chairs. You will find it if you look, but the structure is bad.
Okay, and Tariq?
It's along the same line. I wanted to say that we have a use case wiki that we started somewhere on the the wiki that you're pointing on. It's another page or pointer listed there. I extend this invitation to everybody interested to describe use cases. We did identify a couple of them, and they were noted on the slides that Stuart had presented. So yeah, I mean, definitely we want to cover all the use cases that we want to tackle, so that we can define the solutions that we want or evaluate the options that we have. So my invitation is for everyone to contribute on the use case description there. Thank you.
Excellent. Well, with that, I believe we're done. So thank you all very much. We finished just on time. Everyone have a good evening. This, I believe, closes out the day for Tuesday. And we'll see you all tomorrow. And we'll see most of you in the MPLS working group session. Thank you much.
Dave, do you want me to send you the notes I read out just now, or did you capture them?
Dave, if you're speaking, we can't hear you.
I guess you better send them.
Yeah.
But it won't be till the morning. I don't do much more at 2 o'clock.
Yeah.
Okay. All right. Thank you, everyone. Good night, all.
Okay. Bye-bye.
Good night. Bye-bye.
See you guys.
Thank you all.